Okay, tonight's presentation is Beginner Observing Basic Basics. And Richard and I were talking the other day at one of our star parties, and we thought we have so many new members now and people that have not used a telescope or not been in astronomy, that it might be good to start a series of programs where we introduce them to really the basics of amateur astronomy and observing. So tonight I'm going to give you the basics of the basics. I mean, this is really basic stuff here, but it's where I feel that you really need to begin if you've not been in astronomy before. So the first thing I'm going to do is say, if you don't have a telescope right now, don't rush into buying one, because there are a lot of hobby killer telescopes out there and they can really be frustrating. And you can see the definition of a hobby killer telescope. If you're thinking about buying a telescope, I would suggest going to the Sky and Telescope website and actually reading this article by Jerry Otion and thinking about what he's saying, and then look at the resources, talk to us about our telescopes, do your research before you buy one, and make sure that when you buy one that's worth having and is not going to be a hobby killer, and you're not going to get frustrated and end up like our ex-stargazer here. So learn the basics, buy a good telescope when you buy one. If you don't have the money to buy it now, wait. Buy a pair of binoculars first, or just do visual. Come to star parties and look through our telescopes, but don't rush into buying a telescope. So the beginning basics. First, you need to get some good resources and apps to start with. Start there. There are things that you need to know and have before you go out in the dark. We'll go over those. Dress for the occasion. This is a very important thing to know. And then learn how the night sky works. The only reason I'm doing this is it's amazing how many people, us being in astronomy and doing this for a number of years, a lot of times we assume that people understand what's going on in the sky. But then when you start talking to them, you realize that they have either been taught wrong, or they assume things, or they've read the wrong thing, and they don't understand how the night sky actually works. Next thing is learn your way around the night sky. Learn how to find the constellations. Do you need to know all the constellations? Do you need to know all the stars in the constellations? No, absolutely not. I'll give you some keys on how to find your way around toward the end of the program, but learn your way around the night sky. It just helps to get started. So my goal is that when I finish, that you'll have a pretty good basic understanding of what you need to begin with as you're learning the night sky. So good apps and good references. Of course, Sky and Telescope magazine, astronomy magazine, you can get it at bookstores, or you can get subscriptions to them. They have good basic information, some stuff about the professional astronomers and what's going on, what the new discoveries are. But Sky and Telescope has really changed the way they're doing their magazine over the past few years, and they've gone back to a lot of good observing information and what's going on in the night sky. The Skywatch magazine there to the right is a magazine that they publish once a year. They just started publishing that again last year. And that magazine is good for a whole year, and it has a lot of good basic information for people just getting started. It also has a monthly sky chart, so it tells you what's going on in the sky every month. It gives you, let's say, the lunar eclipse that we had here a while back. If they know something like that's coming up, they'll do a special section on, hey, this is a lunar eclipse, this is what's going on, this is how you watch it. Amateur Astronomy magazine, that is a magazine by amateurs for amateurs. It's probably for a more seasoned amateur than it is for a beginner. but that's a very good magazine. Highly recommend it once you get into amateur astronomy and start learning the ropes. The stars, a new way to see them. H.A. Ray, that is, I highly recommend that book to anybody that's getting started. That book has been around since the early 50s. They continue to update it, but for just down to earth, basic understanding of here are the constellations, here's how you find them, here's what's going on in the night sky, this is the way that the night sky works. That is just an excellent book. It's not a child's book. It may look like it, but it's not. It has some really good information. And it's not very expensive. You can still get it on Amazon. Highly recommend that book. I have like 3 different copies. I have an original 1953 hardbound copy that my uncle gave me many years ago. Night Watch, the book Night Watch is a good book. It's still, I think, for sale on Amazon. Has some really good information. It goes over just all the aspects of amateur astronomy. The Backyard Astronomer's Field Guide, that is a good field guide, but it's more toward people with telescopes. David did a program for us last year about the book, and it's the book is nice. It's not that expensive. The Backyard Amateur Astronomer's Guide, I'll get it right in a minute. This is a brand new 4th edition. It's just come out on the market. It covers just about anything that you need to know or want to know about amateur astronomy. So I don't have a copy of this, but I've seen some pretty high ratings on it. The editor of Amateur Astronomy magazine is actually taking sections of that book and publishing those in the magazine every quarter. Then the book here, the Night Sky with the Naked Eye. Bob King is one of my favorite authors. He writes for Sky and Telescope all the time. He does a blog himself or a website. He just loves observing. He just loves looking at the sky, and he writes all kinds of good stuff. And this book is just full of stuff that you can walk out and look at with your naked eye. He goes through what's going on in the sky, how to find constellations, what are the planets doing, what is the moon doing, different things that like rainbows and halos and all kinds of stuff in the sky that you can see with your naked eye. It's just a really good book, and he just has a really nice laid back way of writing. Of course, you need to know what's going on in the month. All the magazines have a monthly star chart. Of course, the Skywatch magazine has 12 months worth of the star charts there in one magazine. The chart here, you can go online and print them out. They publish those each month with what's going on each month in the sky, and they have just a little star chart along with it. A star wheel or a planisphere, that's Sky and Telescopes. Nice to have when you're learning, or if you want to know, okay, if it's on May the 9th, what is going to be in the sky, what constellation is going to be at a certain time. Those things there are a number of different versions of those out on the market. You can get off Amazon for some of them $60. Some of them run up a little bit more than that, and they're much larger. This is fairly small here, but it's a nice thing to have. They actually have on the Sky and Telescope website, they have this star wheel that you can print off on a printer and make your own. Pretty simple, and it's basically the same thing that's pictured there. This one is in harder, or printed on thicker paper, and is easier to use. And of course, the books that I showed there, they have the monthly star charts in them and tell what's going on in the sky. Once you're ready to invest in a good star atlas, I like the Pocket series that Sky and Telescope does. They they don't go as deep as some as far as magnitude. They don't have as many stars. So it's easier to find things. They don't go into real hard to see objects. And the jumbo series for a person my age is much better because it's nice and big and easy to use. Sometimes I sit around with this star chart in my lap and just while I'm watching TV, just flipping through and looking at things on here, just thinking, okay, I want to see this. But I think the smaller version is like $25, and the jumbo, I believe, is around $45. You can get those from Sky and Telescope. Learn how to use them. There are some good resources on Sky and Telescope website telling you how to use a star atlas or how to use a star wheel. So there's a lot of things that Sky and Telescope has that you can just go on there and read articles that have been published in their magazines or articles that their editors have done to help people. Apps. Okay, everybody needs a good planetarium app on their phone. I use Sky Safari Pro. If you're not, I would recommend not getting Pro right now because it is expensive as far as apps go. But the Sky Safari apps here are not that expensive. They're good. They give you all kinds of good information. They're accurate. It's just a really nice app. The Star Walk is, some of the club members use Star Walk. That's a good app, not very expensive. The Stellarium this is for the phone, and yes, it's a little bit more expensive. If you have a computer, I think there's still a free download of Stellarium that you can put on your PC, and that is a very nice program to have. It just has a lot of information, and you can do a lot of stuff with it. The other two apps here I'm not familiar with, but they were recommended, and if you get those, I guess they'll work also. They're good. They're reputable people that have made those apps. Weather apps, you always want to know, okay, what's the sky going to be tomorrow night, or when am I going to have good skies? And most of these apps here, the My Clear Sky chart has been around for a number of years. Astrophyric is a good, that's the one I use myself. And they have a version of it that the club needs to look at, because if we get it, it won't cost anything. Right now I'm paying 99 cents a month to get the more advanced one. And what he does, he takes 3 different forecasts and he overlays those so you can look. And if all the forecasts agree, you can be pretty well assured that you're going to have clear skies that night. But you'd be surprised the difference in the 3 forecasts. And then it's like, okay, which one? But it's a very good app. The Scope Nights, there are other members that use that, or MetaBlue. The apps on the right, they're not apps. This is the National Weather, the government's weather service, NOAA. And I like the graphic chart that they have, that you can look at the way they predict the clouds or the temperature or the wind over the next few days, and that's really helpful there. Or you can look at the GOES satellite animation to see how the clouds are moving in the sky from the satellites. Okay, things to know and have when you're out in the dark. First thing is you need to learn about getting dark adapted. When you go out or when you go into a dark room, the iris opens up in your eye to let more light in. And that's fine. As you go out into the night sky, your iris will open up. You'll start getting dark adapted. but your eyes don't get fully adapted for about 15 to 30 minutes, depending on your age and the chemistry in your body, because there's actually a chemical change that goes on in your eye that once you're fully dark adapted about 30 minutes into the night, then you would be amazed how much more you can see in the dark. Once you're there, you do not want to look at a bright light. You don't want to look at your cell phone, especially if you don't have it set up the way I'm getting ready to show you. Don't look at any street lights, car lights. If you notice, if we're at star parties and somebody comes driving in a car, a lot of us will turn our back or close our eyes or duck our head to try to keep as much our eyes as dark adapted as we can and not look at the headlights. Always use a dim red flashlight or cell phone when you're out in the dark so you don't mess up your night vision. Okay, red lights are, you can buy red lights. You can make your own. I'll show you the next slide how to make them. The light to the right in the middle, that is a headlight that you can buy at Home Depot or Lowe's. It's nice. It has a red LED in it, but the same button that you turn the red LED on also turns a white light on. So if you touch it one time, the red light comes on, but if you forget and touch it immediately again, you have a white light. Your night vision is gone. That's the only thing I don't like about it. But once you get used to it, you're okay. You just have to remember which button it is, and you only want to push it one time, and you have to let it stay on for a few seconds before you push it to turn it off, or it will turn the white light on. The light in the middle on the bottom is just a simple, inexpensive LED pin light that I got off Amazon. I bought a bunch of them. And in the next slide, I'll show you how to make it a red light. The one to the left is called a zebra light. That is a really nice light. Dennis put me on this light. It's rather expensive, but it is only a red LED. And there's like 4 different levels of brightness. It uses a AA battery, and I can't say that it'll eat a battery up real quick, but it will. If you leave it on for a good while, it will take a battery down pretty quick. Cell phones, Matt, and I think Dennis can also show you how to set, if you have an iPhone, they can set it up so you can pick the home button 3 times, mash it 3 times quick, and it goes from white to a red screen. Very handy. They've set my cell phone up and I love it. So I always do that when I'm out in the dark. I immediately set it to the red screen and use it there. Now, if I go into the Sky Safari app, it will work with that. It stays red, or I can turn the Sky Safari app onto the night vision, like in the bottom there. You always want to do that so it will not bother your night vision when you're using your cell phones. Do it yourself red lights. You can buy red cellophane and just double or triple or 4 layers over the top of an LED flashlight just to get started real quick, and put a flashlight around, or a rubber band around it. Easy way to make it. We do that a lot of times at star parties. We hand out pieces of red cellophane with rubber bands and ask people if they have a flashlight, please put this on it. Do not turn your white light on while you're out here. Or you can go to Michael's and buy a sheet of 651 red vinyl. This is a red translucent vinyl. And you cut a circle out that's just a little bit bigger than your flashlight lens, and you stick it on your lens. And it usually takes about 2 layers of this to dim one of the bright LEDs down to the point that you can use it without any problem. So you can go to Harbor Freight and buy some of their inexpensive LED flashlights and buy a sheet of this and make a number of red LED flashlights to have in all your eyepiece cases, anything you're taking out with you. Keep 1 or 2 of them in your pocket so you always have one handy. Very simple to make and not very expensive. Okay, averted vision, something that it takes a little bit of practice. If you look straight at something, it focuses the light on the back of your retina in the center where you have the cells that are mainly used for bright light during the daylight and color. So the cone cells, that's what they are optimized for. On the side of your eye in your retina are the rod cells, and those are what you see with when it's dark. And if you know where the object is, if you look just off to the side of it, you focus that light on the rod cells and you can see much dimmer things. You won't see color, but you can see that a faint object that you can't see when you look straight at it, a galaxy or something. If you use averted vision, it'll come into view. And it takes practice. You need to, depending on if you're right-eyed or left-eyed, the way I've read here recently, you need to look away from your nose because the cells that are more sensitive are toward your nose in your eye. So if you look away from your nose, if you're left-eyed, you want to look to the left. If you're right-eyed, you want to look to the right. And is the best way to use averted vision. It takes practice. Once you get used to it, you will do it and not even think anything about it. That's a very good tool to have in your toolbox that doesn't cost you anything. You just have to remember to do it. Okay, so what's your angle? Objects in the sky are not measured with inches or feet or yards or miles or anything like that. We measure things in the sky by angles. So you can see the Big Dipper, and the distance between the stars here are marked in degrees. So we're in Chattanooga, we're 35 degrees north latitude. So the North Celestial Pole will be 35 degrees above the north horizon. The zenith is 90 degrees, so it's straight up. The meridian is the imaginary line that goes from due south to due north, and it goes up 90 degrees to the zenith and then back down to the north. So that's the way the sky is divided up. So we'll talk about the meridian being straight overhead and things that cross the meridian or look at the zenith. So we're just giving you directions, and then angles as we go into looking for things in the sky, will tell you that something is so many degrees from a star, or the moon is so many degrees off of a certain object, or things like that. So just think of things in degrees. An easy way to measure degrees in the sky is with your hand. The one that you really want to remember is that 10 degree in the middle. So that is your balled up fist at arm's length. So hold your arm out, and this works for everybody. I don't care how big or how small you are, the way your body is made, your arm is a certain length compared to the size of your body. And 10 degrees is going to be approximately 10 degrees in the sky. So if you read anything that Kelly Beatty at Sky and Telescope or Bob King writes, they talk about something is so many fists away from a star, or so many fists over, or so many fists above the horizon. And that's what they're talking about, is holding your fist out and measuring. So basically, if they say 2 fists above the horizon, they're talking it's 20 degrees above the eastern horizon, or it's 20 degrees from a certain star. So these are handy. This is something you can get off the internet if you can't remember it, and just try to memorize these hand settings, so you can measure. You can look at something and read a description on how to find something, and you know how to measure it in the sky. And it is approximate, so it gets you pretty close. The sun and the moon, are approximately a half degree in diameter, half degree across. So you can take your little finger, which is 1 degree, and you can cover the moon up, or you can cover the sun up. But it's amazing the way the sky is made, that those two objects are almost the same size, And you see in the bottom there, that's why we have such awesome totalities, because the moon covers the sun up almost exactly. And you can see the corona around the top of it. And that was just an amazing sight. Magnitude. Things in the sky are different brightness. So we talk about a star being a certain magnitude. So you can see the picture there on the left. You can see Venus in the middle. You can see how bright it is. And you can see Orion down there in the bottom right. And you see the stars, how Regulus looks big, it's bright, and Betelgeuse is bright, and then the other stars are dimmer. So that's what we're talking about during magnitude, or when we talk of magnitude. So the change in brightness between let's say a 1 magnitude star and a 2nd magnitude star is 2.5 times in brightness. So the 1st magnitude star would be twice as, or 2.5 times brighter than the 2nd magnitude star. And then you go negative. So Vega, that we'll talk about in a little bit here, Vega is about a 0 magnitude. Sirius is 1.4 minus 1.4 magnitude. Venus is about a -4, and you can see here in the picture how bright Venus is. The moon is about minus 12, and the sun is about minus 28. But that's how we measure brightness in the sky, and how we'll talk about stars. You can look at this 4th magnitude star and start there and star hop over to find an object from that star. Now, in your apps and on star atlases, the only way they can show the brightness is to change the diameter of the star itself. So like in this picture, Sirius is the bright one down in the bottom, and you can see it's larger in diameter than some of the others, and they will change the diameter of the star to indicate brightness. And in a star atlas along the side, there will be a magnitude scale that shows you the circle diameter of a certain magnitude star. So when you go to the atlas field, you can see what the bright stars are and dim stars and dimmer stars. So that's how they have to do it to be able to show magnitude. Magnitude is something you need to know and understand what it is. Okay, when you go out and you look up, you always want to try to look at objects when they're high in the sky, because you can see by the illustration here, if you look at something down toward the horizon, you're looking through a lot more atmosphere than you are looking higher in the sky or straight up. So the more atmosphere you look through, the more wavy that object is going to be, the more twinkly the star will be, the fuzzier the object will be. So take advantage of looking higher in the sky and looking through less atmosphere than looking toward the horizon. And the sky is usually darker the higher you get in the sky, depending on how bad your light pollution is. In astrophotography, we will never, unless we absolutely have to, we will never photograph anything below 30 degrees above the horizon. So we will sit and wait for an object to come up to at least 30 degrees before we ever start trying to image it. Light pollution is something we have to deal with. It's not going to go away. It's going to get worse. So you just have to learn ways to deal with it and get around it. The star map, or the dark sky map here, is of Chattanooga, and the one on the right is 2016. The one on the left is 2006, and this is up on mine and Astro Matt's end of town. I don't know why the map on the left has nothing about downtown Chattanooga being white out, but between 2006 and 2016, apparently downtown got a lot brighter because now it is white out in downtown. So you can see on the outside of that, there's a brighter red, and it goes to a dimmer red, and then to an amber, I guess, a sort of brownish color, and then yellow. And each one of those is the level of light pollution as you go away from Chattanooga. So the blue arrow there is my house, and I'm right on the edge of that red zone. So we're in about a 7 to 8, border 7 to 8 or 8 or 9. I still haven't quite figured out exactly what level we are, but it's pretty bright. From my house, in fact, right now, the ball field lights are already on for some reason tonight. That's what it looks like from my house, because I'm looking right back at Red Bank High School, and I think there are 6 ball fields and a soccer field and a football field. The football field lights usually aren't on the same time the ball field lights are on, but that's what it looks like in the spring and the fall when ball season, baseball and softball season hits here. And if soccer is played on the same night on the other side of the high school are the soccer fields, and those lights will be on also. So on those nights, I just forget about doing any visual at all because everything is lit up around here. So I have to wait until the lights go off before I can do any observing. So there are things that you can do if you can't get out of town. It's one of the reasons we go to Cloudland Canyon. One of the reasons we used to go to Fall Creek Falls is to get out of Chattanooga into a dark area. If you're lucky like Harold, you are out already, and you have beautiful dark skies with almost no light pollution whatsoever. Lucky. Okay, if you can't get out of town, then try to find a dark area in your yard. I do my observing in my backyard. I have a neighbor that turns on their back porch light. I use the light shield. I have pieces of conduit and PVC pipe that I hang tarps from Harbor Freight off of to shield Jill's back porch light when I'm out trying to observe visually. If I'm imaging, I usually don't have a problem, but visually I do. The neighbor to the back, I could take a picture right now of his lights that are on. There are 4 LED flash or 4 LED lights that are basically pointed at my house. But Chris is real nice. If I'm out with a telescope, as soon as I go out, his lights come on a timer. I just text Chris to say lights, and he immediately turns the lights off for me. Nice having neighbors that have agreements like that. You can find shadows around your house if you have lights. You can just getting in the shadow away from a light, shielding that light off of you will help. The last thing they say that to observe after 11 o'clock when the business turns their lights off, I honestly don't think that works anymore. It does with the ball field lights for the most cases. There are some nights that lights are on till after midnight because they play tournaments and they will play until after midnight. So that doesn't work a lot of times, but you just have to work around light pollution. It's not going to go away. If you wait, say, I can't observe from here because I can't get away from light pollution, then you're never going to observe. The best thing to do is find ways around it and go on and observe. There are things that you can see even in light polluted skies. Even from downtown, there are things that you can look at. You may not get to some of the faint deep sky objects, but clusters and things like that, if you have a telescope, you will be able to see them. Dress for the occasion. If you're zoning out on me going to sleep, you better wake up for this one, because of all the other things that I say tonight, this is probably the most important thing that I have to say. You need to dress for the occasion. And I made this a rule number 1 because I couldn't tell you how many times I have gone to star parties or people have come, we've been out and we just have not taken enough clothes, and we've had to pack up and go home because we got cold and we couldn't stay out any longer. Once you get cold, it's very hard to get warmed up again. So be sure, take more than you need. If you think you don't need it, take it anyway. It's better to have it in the car and not need it than to not have it with you and need it. I've seen other things like people forgetting cables, people forgetting counterweights and things like that. Hey, Dennis and Matt can talk about this. Dennis left his counterweights off of one of his small mounts one night, and we taped a hammer and I forget what else to the back of his telescope. And he went ahead and imaged that night with a hammer taped to his telescope to replace the counterweight. When you get cold, you can't do anything. Hand warmers, hot hands are really good to have with you. The best thing I found is that little rechargeable hand warmer. Has 3 different heat settings. You can turn it on, turn it off. When you get back home, you just recharge it and it's good for the next night. If your hands get cold, you can turn it on right quick, warm your hands up, turn it back off, stick it back in your pocket, and then pull it back out when you need it again. Hot hands, once you turn them on, they're on. You can't turn them on and off, and they gradually run down. Of course, the rechargeable hand warmer will run down also, but it will run more than a night. You can also charge your cell phone with it. Be prepared for bugs. Always be prepared for bugs. If you see me, I did some research here a few years ago, and I found that you do not want to wear a t-shirt. You don't want to wear anything that has a loose knit to it, because mosquitoes can and will bite you through a t-shirt. But if you wear something that has a real tight weave, like a nylon hoodie or a nylon pullover, these sunblock shirts, you can pull those on. They're not hot, but the weave is so tight that mosquitoes cannot bite you through the shirt. They'll get your hands, but you spray your hands, or get you a thermal cell and turn that on for a while and chase them away. And you can turn it off, turn it back on if they come back. Those things are pretty neat, but be ready for bugs. Don't go in short pants. Wear long pants. Get a thin pair of nylon pants, the guide pants, things like that. They're light and they won't bite you through that nylon. But if you wear a pair of short pants, your legs are free game for them. And if you're like me, they will eat you up. Okay, learn the night sky, how it works. This is all naked eye. You do not have to have a pair of binoculars. You don't have to have a telescope or anything for any of this. And again, I'm saying this, I know most of you know this, but it's amazing how many people don't understand how the night sky works. Okay, the night sky rotates. Yes, it rotates because Earth rotates. So apparently what it appears is the objects will rise in the east and set in the west. It's actually Earth rotating to the east, and we're rotating into the objects. So it appears to us, because we're riding on Earth, that the objects are coming up, and the sky is actually rotating over the top of us. So the North Celestial Pole, everything rotates around it. And if you look in the middle of Matt's picture right there, you can see Polaris is right there, and everything is rotating around it. So that's the first thing you want to learn about the night sky. So if you look, let's say January 1st, 2020 at 8 o'clock, if you look to the east, there are the stars that are coming up. If you stay up till 4 o'clock in the morning that night on January 2nd, and you look to the west, you'll see the same stars going down in the west. That's the way the night sky works. Okay, now the next thing is a sidereal day versus a solar day. Our clocks and our calendars are all set up on a 24-hour solar day. The night sky, on the other hand, is set up on a sidereal day, and that's based on Earth's rotation relative to a fixed star or fixed stars. So if you go out, this is January 1st, 2022 at 8 o'clock, and let's say you have a power pole at the back of your yard, and you put at 8 o'clock that Capella is right at the top of that power pole, right there. So you say, okay, it's 8 o'clock. Capella's right here. You mark where you're standing, and you come back the next night. Well, a sidereal day is 23 hours, 56 minutes, and just a little over 4 seconds. And if you don't know, this is why leap year is put into our calendar, is to make up for this difference. A lot of people don't understand that. They don't know why leap year is in there. You go out on the next night and you look for Capella. At 8 o'clock, the top of the power pole is going to be about right here, because Capella passed the top of that power pole 4 minutes earlier than it did on the night before. If you go out at the end of the week, 7 days later, it's 28 minutes. It passes the power pole 28 minutes earlier. If you go out February 1st, it's 2 hours and 4 minutes. So you can see the difference. And this is why the sky changes, and why we have seasonal constellations, is because the sky is rotating, is moving over us 4 minutes, advancing 4 minutes approximately every night through the year. The ecliptic. Okay, this is the path that the sun, the moon, and the planets follow. So if you walk out and you think about, okay, the moon follows about this path, or the sun follows about this path from the west to the east every day, and you look at that arc across the sky, that is the ecliptic. That is the plane that all the planet orbits are on. So if you look up the sky and you see a bright star, which if you go out, if it was clear tonight and you go out and look toward the west, you would see a bright star over there. And that bright star is not twinkling. That's Jupiter. So you can tell where the planets, so you know about where the planets are by just looking at the moon, watching the moon as it goes across the sky, or watching the sun about where it is in the sky. And then when it gets dark, looking at that arc that those two objects follow, and look, that's where the planets go. That's where you can see the planets. So that's called the ecliptic. The lunar cycle. I didn't think much about this until somebody came in my office one day at work and said, "Where did the moon go? What happened to the moon?" Chris, what are you talking about? Well, I went to take the dog out this morning and the moon's gone. Yeah, okay. So as we talked on, I realized that he had gone out a few days before, took the dog out, and the moon was up. Then there were a few days of rain. So when he took the dog out, he didn't see the moon. And then this morning, that morning, it was clear and he walked out and the moon's gone. Well, okay, the moon moves, Chris. The moon is not always in the same place in the sky every night. It moves, it rises about 50 minutes later each night, or about 12 to 13 degrees later each night. It moves toward the east. So when you have new moon, or let's say full moon. So when you have full moon, 7 days after full moon would be last quarter. When you see a crescent moon first coming up, that would be right after new moon. Then about 6 to 7 days after that, you'll have first quarter. 7 days after that, you'll have full moon. 7 days after that will be last quarter. 7 days after that will be new moon. So the moon goes through about a 29 and a half day cycle of all its phases, and then it goes new moon, and then it comes right back up, starts in the west again, goes right back across the sky. That is just part of the sky, the way it works. So understand why we see the phases. Learn to find your way around the night sky. Okay, again, you do not have to know all the constellations. You do not have to know all the stars in the constellations. The easiest thing I find is there are 16 bright stars that if you know how to find those bright stars, you can get pretty well oriented in the sky just about any season of the year. The first thing you want to be able to find is be able to find Polaris. And to do that, we don't use constellations, we use asterisms, sorry. And an asterism is a pattern, easy to recognize pattern or grouping of stars. It can be part of a larger constellation, or it can be stars from different constellations that end up making a pattern that is easily recognizable. So the Big Dipper is probably the most recognized asterism of anything in the sky other than maybe Orion. And the Big Dipper is part of the constellation Ursa Major, the Big Bear, and you can see how it's, and this is H.A. Ray's depiction of the Great Bear. That's Ursa Major. So that the Ursa Major is the constellation. The Big Dipper is the asterism of the Big Dipper, part of Ursa Major. So we can use parts of constellations or asterisms to point us to find the bright stars in the sky. So one of the first things to learn how to find is Polaris, the North Star. You go to the end of the Big Dipper, to the two stars in the end of the Dipper. You follow the line that those stars, look through the line through those stars. You follow that line, and it leads you to Polaris, about 5.5 times away, or 5.5 distances between these two stars here. If you go 5.5 times, you'll get here, or 2.5 fifths from that star will get you to Polaris. And I put this note down on the bottom that the North Star is not the brightest star in the sky. And I'm amazed at how many people have been taught that in elementary school. And when we talk to them at star parties, ask them, do you know how to find the North Star? Yeah, it's the brightest star in the sky. No, it's not the brightest star in the sky. So learn how to find that. It's very important, especially once you get a telescope, if it's an equatorial mount. Okay, another way to find another star is Regulus, which is in Leo. So in the spring, later, well, it's just starting to come up now, but you can go to the opposite side of the Dipper, the two stars there on the handle side, and you can follow the line that those create, and you can go over and find Regulus, that is the brightest star in Leo, the line. Here's another one you can use the Big Dipper for, arc to Arcturus and speed on to Spica. The Spica end of it depends on what you read, is how it tells you to go to Spica. But basically you follow the arc that the handle creates, and you arc around and you come to Arcturus. That star is no problem to find. It is very bright. And then arcing on to Spica, or spiking on to Spica, speed on to Spica, is again in the spring. That's an easy way to find Spica. It's not that hard to find, but Spica is in Virgo and Arcturus is in Boötes. During the summer, we have the summer triangle. There are 3 stars, Vega, Deneb, and Altair. Easy to find, good way to locate things. There are objects all around these stars that you will come back to hop to find the objects. So the summer triangle is something we always show people in the summer. Hey, look at these 3 bright stars here. That's called the summer triangle. Well, that's an asterism, the summer triangle asterism, and 3 of the brightest stars in the sky. Later on in the summer, when the Milky Way starts coming up in the south, Antares in Scorpius is a red supergiant, easy to see, has a red cast, and I think Arcturus translates as rival of Mars, I believe is the way the translation is, because the color of Arcturus in the sky is very, very similar to what Mars looks like when it's up, and it's bright. It has a reddish cast to it, but it's also in the constellation of Scorpius that actually looks like the scorpion that it depicts with the curved tail. And these are the pinchers up here. So that's the bright star down in the south during the summer, late summer, fall. Okay, winter, you have the great square. So you have Pegasus, and this asterism here is easy to find. It's very large, but you can also use it to find some of the brighter stars. You can use the diagonal to go across and find Deneb, which is part of the summer triangle, or you can use the southern section, the southern side of the great square, to go across and find Altair, which is another one of the stars in the summer triangle. Or you can come off the other side and find Fomalhaut, I think I pronounced that right, which is down by itself. With the light pollution from my house there, I can hardly see any stars around it at all. Just a few of the brighter stars because it's down almost over town, and it just sort of hangs out there by itself. But you can jump from it to find there's other constellations around it to locate things from. Right now, the winter hexagon, and it's more than in this picture, it's more than a hexagon. If you look at some of the online versions of the winter hexagon, excuse me, it does not have Castor. It goes from Capella down to Pollux because Pollux is brighter than Castor, and they leave Castor out. Bob King, on the other hand, says, hey, you know, Castor is just a little bit dimmer than Pollux. I'm adding it in. So I followed his way of thinking, which I agree, because that adds one of the other bright stars that's on the list of 16. So you come from Capella, that's right now pretty high in the sky. It's very bright, easy to find. You come down to Castor and Pollux, the twins, easy to find because they're right together or in a line. So you just look and there's no problem finding them. You drop down below them and you have Procyon that's in Canis Minor. Come on down, and this star, the brightest star in the sky, Sirius, no mistaking this star. And then from there you go up to the foot of Orion, Rigel, and from Rigel you go up to Aldebaran in Taurus, and then back to Capella. The problem is this leaves out one more bright star in Orion that the hexagon leaves out. So Bob adds the winter G. So here he starts at Aldebaran in Taurus and goes from there to Capella, down to Castor, to Pollux, to Procyon, to Sirius, to Rigel, and then he sort of dodges up to one of the stars in the bow of Orion, and then across to Betelgeuse. So now you have the winter G. You can go out now or to about 11 o'clock. I think all these stars are up. Maybe not even that late. They may be up now behind the clouds. This is the winter, and these are all very bright, very easy to find, and just tons of things to look at around them. A lot of fun. So this gives you a good basic way to find these bright stars. From the bright stars, you start learning pieces of the constellations. Like Orion it is not, most everybody knows Orion by the 3 stars in the belt, the shoulder stars, and the stars at the feet. Okay, that's not the constellation. That's just the asterism of the main body of Orion. And you can see there's an arm out here with a bow and the arm up here with a club. So there's more stars in the constellation, but you don't really need to know these. You just need to know they're there. And then when you start trying to find an object with the star atlas, these stars will play into that. But the main thing is find these main asterisms that can start locating some of these constellations and start learning from there. These constellations out here, you will get to them, but mainly from the star atlas. You don't need to know where they are. You just need to know they're there. And once you read something that says, okay, it's in the Beehive clusters over here in Cancer, you just need to know it's very faint. This constellation is very hard to find because the stars are very faint. From my house, I don't think I can even see these stars, but the Beehive's right here. You can see that with a pair of binoculars. It's a beautiful cluster. So final thoughts. Dang. Okay. These are the basics as I see them. This is the way I feel about them. I'm sure I left out some things that somebody could say, hey, you should have said something about this. That's fine. These are the ones that I remember. Don't stop here. There's all kinds of things out there that you can learn, just amazing things. So this is just the beginning. The more you get out and look, the more you're going to learn the night sky, and the more you're going to see. If you don't get out and look up, you're not going to learn the night sky. You've got to be out under the night sky. You got to be there. It's just an amazing thing to just stand and look up at what's going on up there and what there is up there to see. The more you get out and observe and try to see the detail, the more you're going to learn how to see that detail, and the more you're going to see. It's all learning how to train your eye to see the things. Prepare beforehand. If you know tomorrow night's going to be clear, sit down tonight, get your magazine out or your atlas out and look, okay, what's going to be up tomorrow night? What can I see? What do I want to look at? Make your little list. So then when you go out tomorrow night, you're not saying, oh, okay, what do I want to see now? And then by the time you decide, some of the things have gone that you would probably like to see, but you spent time trying to figure out, what do I want to see? Go out with the list so you're there and you're off and running as soon as you get out. Make it a good habit from the very beginning. Start keeping an observing logbook. We're going to have more information on this later on, a few months down the road. I'm going to have someone come in to talk to us about doing a logbook, and it's just amazing what he's done with logbooks for years, from the time that he was a teenager till now, and the amount of information that he has in his logs. It's really neat what he's done. Be patient with yourself. Be patient. Don't get upset. I can't do this. I can't do that. Be patient. It just takes time. You've got to learn this. You got to walk before you can run. So be patient. Above all, get out and enjoy the amazing sky. It's just so much fun. So go out and have fun. The end. Anybody have any questions? Everybody's going to sleep?
No one's gone to sleep. Ralph, this was fantastic. Does anyone have any questions for Ralph?
How do I get back, Matt?
It's okay. Just leave your screen up there, Ralph. It's fine. Anybody have any questions? Okay. Ralph, you're getting lots of people thanking you for doing this, saying they learned a lot. So we'll end the stream here. Folks, thanks for watching with us. Ralph McConnell, thank you for presenting. This was fantastic. If you have questions and you're joining us for the first time tonight, please just follow up in the thread or post your questions, and we'll answer them the best we can. Thank you for coming tonight, and hopefully we'll be back in person as soon as we can. So, Chris, take us out.